In this video, we'll be learning all about polynomials and a lot of key vocab terms related to polynomials. We'll be learning about what makes something a polynomial, how to write them into what is called standard form, and then we'll be learning how to determine their degree, type, and leading coefficient, as well as popular names on how to classify them. So to begin, let's just describe what a monomial and a polynomial are, because monomials actually make up polynomials. So a monomial is a number, a variable, or a product. And remember, product means multiplication. So, or a product of a number and variable. So that's what those are at a very basic level. So that means a monomial could be something like 10, or something like x, or something like 5x squared, y to the third, z to the fourth, because that's a product or a multiplication problem made up of numbers and variables. So that's what a monomial is on a basic level. A polynomial is either going to be just a monomial or a sum of monomials. So basically what a polynomial is a bunch of monomials added or subtracted together, because if they're subtracted, it's just a negative term. So each one of those monomials in a polynomial is called a term, and it'll have a basic look that looks something like this. So you can see that we have, this a sub 1 and a n sub 1. Those are just coefficients. These are just coefficients in front. So you can see we have coefficients in front here all the way through, and then we have these terms here with variables that have exponents on them. So when we work with polynomial functions, this is the general form they are going to be in. And the things that you have to know about them is all of the coefficients are going to be real numbers, which means there's going to be no imaginary I, and all of the exponents will be whole numbers. Now, the easiest way, I think, to determine if something is a polynomial is really to look for things that cannot be within a polynomial. So things that cannot be within a polynomial include negative exponents. So you can't have something like 5x to the power of negative 3. That's something that you cannot have, that is not allowed. You can't have a variable exponent. So something like, 5 to the power of x. That is not allowed either. That's called an exponential function. You can't have fractional exponents or roots. So you can't have things like, 5x to the power of 1/2 or 5 times the square root of x. You can't have those values in there. And you also can't have variables in your denominator. So you can't have something like 1 over x squared. These are all things that are not allowed, and if you see these, they automatically make something not a polynomial. So let's do a little practice here and quickly look for things that are not polynomials. So I have 7 different expressions here on the screen, and we're going to look at each one really quickly and decide, is it a polynomial or is it not? So if I look at this first one here, I notice that it looks okay until I see a variable and an exponent. That's something we're not allowed to have, and because it has just one variable and an exponent, that one's out. This one, when I look at it, it just has numbers, variables with whole number exponents, and they're being added. So this one is good. The next one over, I notice that there's a negative exponent, and that's on my list of things that a polynomial cannot have. So that's automatically out. The next one, while it maybe doesn't look like a polynomial, it doesn't break any of the rules. It's a number, and that's a monomial, which also classifies as a polynomial. This next one here, just like number 2 here, has just variables with whole number positive exponents and coefficients, so this one is good. This next one here has a variable in the denominator, which is breaking a rule, so this one would not be a polynomial. And this one here has a square root, which again is something that cannot be in a polynomial, and as a result, that one is also not a polynomial. So here, this is asking us to write a polynomial into standard form. And standard form we've worked with quite a bit. A polynomial written in standard form is simply a polynomial with the terms written in order from highest degree, which is essentially going to be the highest power. so highest degree, which is the highest power on a variable, to the lowest degree, or the lowest power. So for in this one, what we're going to do is we're just going to rearrange this so that the highest powers come first and the lowest powers come towards the end. So when I look, I see 2, 4, 3, and this is a power of 1. So this term would become first. That negative sticks with the 3. And then this term would be second because the x to the third is the next highest, followed by 4x squared, followed by 5x to the first. So all writing things in standard form is rearranging them so they go in order from the highest power on an exponent to the lowest. So now we're going to talk more specifically about what the degree of a polynomial is. So I know we talked about putting things in order from highest degree, but degree of a polynomial is a little bit different. The degree of a polynomial is the highest degree of all of its terms, and the leading coefficient is the coefficient of the first term in a polynomial when a polynomial is written in standard form. So what we're going to do with each of these is we're going to write them into standard form, then determine their degree and their leading coefficient. So when I look at these examples here, I first need to put them in order from highest degree to lowest degree. So I'm going to start here with 5x to the 6th, then negative 3x to the 4th, followed by 4x, and then the 2 comes last because it doesn't have a variable with an exponent, so it's just the last one in the group. Then from here, we need to find the degree of this polynomial, which if you write it in standard form, will be this first power here because it is the highest. So this is a 6th degree polynomial. And then from here, our leading coefficient, when we write it in standard form, is this first coefficient. So our leading coefficient here is going to be 5. If we apply the same thinking over here, we're going to put them in order first. So we have negative 2x to the 5th minus 5x to the 4th plus 3x to the 3rd plus 0.5x. And then here again, I'm looking for highest power, which is right here. So my degree is going to be a degree of 5, or the 5th degree. And then my leading coefficient, which is the first coefficient when this is written in standard form, is negative 2. So what we're going to do in these last 2 slides is we're going to really look at other key vocab terms that are related to polynomials and types or different common words that are used to describe them. So first thing we're going to look at are how we can classify types of polynomials based on their number of terms. So the number of terms is how many things are being added or subtracted together. So for example, in this first example here, this would have 1, 2, 3 terms, okay? And so we can have either 1 term, 3 terms, 2 terms, or higher than 3 terms. And I'm actually going to make this a little bigger here because those lines on the ends over there aren't very long. So we're going to make these a little longer as we classify. So first thing is, if we have a 1-term polynomial, that is commonly called a monomial. We already saw that word, but think about it as mono as a typical word used for 1. If we have a 2-term polynomial, this is typically called a binomial, because it has 2 terms, and we see the word bi a lot to describe 2, so think of it like bicycle has 2 wheels. That's a common word that, or a common prefix that's used for 2. For 3 terms, we have a trinomial, which again, if you think about like bicycle and tricycle, a tricycle has 3 wheels, while a trinomial has 3 terms. And then anything higher than 3, we just describe as a polynomial. So what we can do is we can describe polynomials by both their degree and their type. And so I'll kind of walk through that quickly, what that looks like for these examples here. So we already talked about how this first example has 3 terms, and we can see that its highest power is 7. So this would commonly be described as a 7th degree trinomial because it has a highest power of 7 on a variable and it has 3 terms. This next one here would be described as a fourth degree because 4 is its highest degree on a variable. And because it has 1, 2 terms, this would be a fourth degree binomial. This one here has 1, 2, 3 terms as well, and it has a highest power of 5, so this would be a fifth degree trinomial. This one here has 1, 2, 3, 4 terms, and its highest power is 9, so we would have a ninth degree polynomial because it's over 3. And then finally down here, this 12 doesn't have a degree because it doesn't have a variable with an exponent, so it would be a 0th degree. And then this would be, with one term, a monomial. And then finally, I wanted to just highlight some other common names that we've actually used quite commonly for polynomials. We've talked about these before. So if something has a degree of 0, the type that it typically has that you'll hear us use in math is called a constant. We've talked about these before when we've graphed them on lines. They're typically just horizontal lines on a graph. And an example of a constant is just f of x equals -14. So that's just where there's no variable at all, and there's just a number. A linear function is for things that are degree 1, which again we've seen before, like 5x minus 7, 1/2 x plus 2, whatever it might be. We know that when x doesn't have an exponent on it, it's just an exponent of 1, and that's the highest power, that we have a line or a linear graph. When things are degree 2, the term used to describe those in math is quadratic. We've talked about these quite a bit. These are our parabola-shaped graphs. They have that U shape, and they have a highest power of 2. And then the two new ones we're going to look at this chapter and see a little bit more are cubic functions, which have a highest power of 3, and quartic functions that have a highest power of 4. So these are just common names that are used to describe them. And you'll hear mathematicians and math teachers use these terms a lot. And so just being familiar with how their degree associates with these special type names is just an important thing for Algebra 2 students to know.